Hello everyone, and welcome. Today we're going to talk about inference endpoints, how we can make those powerful AI models accessible to just about anyone, and how we scale them for maximum ROI. We'll focus on how to actually deploy a Llama 3 model using Avasa's Elastic GPU Service, or in short, EGS. Yeah, keep things easy, nice and snappy. So first things first, what is EGS? Why should we even care about it in the context of AI? EGS is like a toolbox for deploying and managing AI models and the infrastructure behind them. And what makes it stand out is its flexibility. So it doesn't matter if you were an individual data scientist who just kind of likes tinkering with AI, or if you're a large organization working on something super complex, EGS has got you covered. EGS can work for like anybody. Let's log into EGS. You can use your existing accounts like Google, GitHub, or Okta. And if you need extra security, EGS also supports service account tokens and kubeconfig files. Here we have a workspace. It's called a Musk workspace. A workspace is essentially your dedicated sandbox just for that project. So your work or your team's work stays completely isolated from other users. So this workspace is in the Avasa worker cluster. Now we'll set up an inference endpoint in this Musk workspace. An inference endpoint is basically how you interact with your AI model after it's already been trained. So it acts like a doorway, allowing you to send data to the model and get back results. So let's click on Create Inference Endpoint. So we'll create an endpoint for Llama 3.2, 8 billion parameters, which will be hosted on that Avasa worker cluster using the Hugging Face model format. Why are we using Hugging Face? Hugging Face is kind of like a giant library of AI models. Using a pre-trained model from Hugging Face allows you to skip the super lengthy and resource-intensive process of training a model from scratch. So now for some optional customization. We can mention we need, say, 6 CPUs, 24 gigabytes of memory, and some specific arguments. So allocating resources is super crucial. All this is customizable for your endpoints using EGS. Next, you can say you need an H100 GPU specifically and the CPU memory requirements if you know all of these, but these are optional parameters. And then click on Create Inference Endpoint and create your endpoint for the Llama model from Hugging Face in your Avasa cluster infrastructure. The request enters a pending status while EGS kind of works behind the scenes. Eventually, that pending status is going to change to running, which means that your Llama 3 model is live and ready to process information via this URL. So this is the inference endpoint. That's the doorway to your fully functioning Llama 3 model that can generate text, translate languages, and do all sorts of really cool things. Now, what about scaling those inference endpoints? This is where Smart Scaler comes in. It monitors real-time traffic patterns to your inference endpoints and dynamically adjusts the number of pods needed, scaling up when demand spikes and down when it's low. That means precise resource allocation, lower costs, and faster response times. With Smart Scaler, you save costs, improve performance, and maximize your ROI on inferencing. That's it. EGS makes deploying AI models easy, scalable, and efficient. Give it a try and let us know what you think.